Once again, good morning, dudes. Today we will see one problem in moment of inertia. Okay, I think we have seen this particular problem. I think so. Find the moment of inertia of an angle section shown in the figure about its centroidal axis. Please underline that word centroidal axis. So first we have to calculate the centroid because they have asked about the centroidal axis. This L section is divided into or subdivided into two sections. That is like this, that is 48 into 12, that is one section. Another one is, you know very well that 40 by 12. Okay, these are the things. Please listen carefully. Those who have solved, those who did not solve along with me. Okay, so once we divided like this, so this one I am taking as a first section, this one I am taking as a second section. Okay, shall we proceed?
Yes sir, proceed sir.
Okay, fine. Okay, so this first and then this is second. So now in the section 1 we have to calculate the area. We know that is 48 by 12, so we got 576 millimeter square. Okay, and with respect to this axis, please make a note of it. Okay, it is not about the base of the rectangle, it is about the axis what we have given us. Okay, that OX and OY. With respect to this axis we have to calculate x1 and y1. And this center axis will give, okay, the x1 value, that is this particular distance is nothing but x1. So when you are calculating x1, the total distance is 12. So 12 by 2 will give you x1. Any doubt in this?
No sir, 12 by 2.
Okay, fine. So x1 will be equal to 12 by 2 is equal to 6 mm. Got it? Now we are moving to the y1. Okay. So you know very well that this particular, again I will repeat, see here, this particular axis is the center of the section 1, okay, in the L section. So when I am calculating with respect to OX axis, this distance will be 12 plus 48 divided by 2. So then this particular length is y1. So now y1 will be equal to 12 plus 48 by 2, that is equal to 36 mm. So next one, we are moving to the section 2. You can see here we are having the section 2, 40 by 12. So now again you have to calculate this particular x2 distance. So you are drawing a centroidal axis of this section. So this length will give the x2. So this x2 is nothing but the total distance divided by 2. The total distance of this rectangle is 40. So 40 divided by 2 is 20 mm. Hope you got it. So now next one, you are going to calculate the y distance of this rectangle. So with respect to x axis you have to calculate. So you can see this particular vertical height is your y2, 12 by 2, that is 6 mm. So once you got area 1, x1, y1, area 2, x2, y2, then we can calculate the centroid, that is x bar, that is a1, x1 plus a2, x2 whole divided by a1 plus a2. You got 12.36 mm. Am I right? 12.36. Is it correct?
Yes, sir.
Yes, sir. Similarly, y bar, if you are calculating a1,
22.36.
yeah. So now we have calculated the centroidal axis, that is x dash and y dash. This value is how much? Can you tell me now? Section 1 and section 2 will have its own centroidal axis. Am I right?
Yes, sir.
So now listen carefully, all of you. So this is the center of what section? This particular line.
X, sir.
The first
Section 1. Sir, 2.
Section 1. Yeah, section 1. Am I right? Section 1 centroidal axis of XX. Am I right? Section 1
Yes,
centroidal axis. Am I right?
Yes sir.
Yes, sir. Okay. Now x dash is equal to this line. Whether these two are lying on the same line or different line.
Different sir.
Different line. So now listen. Okay, very good. It is different. Okay, the common centroidal axis is different. The individual section centroidal axis is different. Now the second moment of area is nothing but between these two axes, x dash and the red line. Are you getting? So now listen carefully. Whether this vertical line, okay, that is, this is related to section 1 or section 2. The green line.
Sir,
Section
the
1.
green line, sir.
Yeah, green line. Wait, again.
Section 1, sir.
Section 1.
Section 1. Yeah, section 1.
Green line passes through the section 1's
Yeah.
center.
Parallel to y dash y.
Yeah, exactly. Very good. So this is related to section 1. Okay. Whether this line and y dash are same, whether it is lying on the same line.
Same plane, yes.
Not
Same line. I'm asking
No,
whether
not the
these
same
two are in
line.
the same line. No.
No, sir.
So now I'm asking one question. The red line and the xx dash, these two are parallel.
Yes, sir. Parallel.
Yes, sir.
Yeah. Similarly, the green line and y dash, these two are parallel.
Yes, sir.
Yes, sir.
Yes, sir. Yes,
So
sir.
do you understand now the common section centroidal axis and the individual section centroidal axis? Did you understand now?
Yes, sir.
Listen here. Whether this is, what is the value of this particular line? Any idea?
6.
6.
Yeah, that is nothing but x1. Am I right?
Yes, sir.
Okay. Now, what is this one? This entire length?
12.36.
Well, what is the value of that? Yeah, 12.36. That is nothing but what?
12.36.
That is nothing but what? X bar.
X bar, sir.
So now I am going to calculate the distance between these two because I am going to calculate the moment of inertia with respect to y dash. Got it?
Yes, sir. Yes, sir.
Okay, now this is h. H is equal to x bar difference x1. Please make a note of it. Similarly, can you help me here? What is this value? Entire value?
Y1, sir.
Y1. Very good. So this value is y1. Very good. What about this value?
Y dash.
What is that?
Y
dash.
Y bar. Am I right?
Yes, sir.
Okay. Then what about this value?
Y1 minus.
Y1 minus Y dash.
Yeah, y1 minus y bar.
I'm getting a very big value, sir.
wait. Are you getting the concept? No. Forget about that.
Yes,
Are you
sir.
getting the concept now?
Yes, sir.
Okay. Do you understand what is h now with respect to xx dash and what is h with respect to y dash?
Yes, sir.
Okay. So now moment of inertia. So whether all of you are listening, can I ask Vignesh to read again? Shall we go to the definition now?
Yes, sir.
Yes, sir.
Okay. Tell me, boy, Vignesh, the definition. The sum of the
The sum of the moment of inertia about a
wait.
parallel
Sum of the moment of inertia about
a parallel centroidal axis.
parallel centroidal axis. Now you people say that which are the parallel centroidal axis? Tell me.
Sir,
The
that
green line and y
Sir,
dash.
for
Very
OY
good.
it is Y
Green
dash.
line
And the y
yeah, very
and y
good.
dash.
Green line and y dash is the parallel lines, right? Centroidal axis. Am I right?
Yes,
One
yes,
is
sir.
with respect to the entire section. Another one is related to the only one particular section. Am I right?
Yes, sir.
Yes, sir.
Green line is related to only one section. Y dash is related to the entire section. Am I right? These two are parallel. Any doubt in this?
No, sir.
Okay. Similarly, xx dash and red line is parallel. Am I right?
yes, sir. Red line
Yes, sir.
and H.
Yeah.
Sir.
Now sum of the moment of inertia. Yeah. Tell me, Vignesh.
About a parallel centroidal axis in the
Yeah.
plane of the lamina
Okay.
and the product of the area
Yeah.
of the lamina and
Okay.
the square of the distance between the two axes.
Can you tell me the square of the distance is what with respect to green line and y dash?
H square.
Very good. Did you get now?
square, sir.
X bar
H
differentiate x1 whole square is the distance square.
Difference
Got it
between-
now?
Yes, sir.
Yes,
Similarly,
sir.
for xx dash and the red line, which one is the distance between the centroidal axis?
Y bar differentiate Y1.
Very good. Y bar differentiate y1. Are you getting? So now, as per Vignesh, this is the formula based on the parallel axis theorem for moment of inertia. Ixx is equal to ICG. What is this ICG?
Centroid.
So centroid
Moment of inertia about the centroidal axis of each section. Please take,
that is
please take down.
V x
ICG
cube by
means,
12
yeah, very
for
good.
rectangle.
Yeah, please take down. ICG means moment of inertia about the individual section. Okay. For rectangles means we have studied BH cube by 12. Am I right? That one.
Sir?
Yeah, tell me.
So why did you say y bar differentiate y1? Isn't it minus?
No, it should not be minus because you can see that always we are seeing the distance only. So it should not create a problem in minus. Are you getting?
Okay.
Differentiate you
Okay.
take. Why I am saying is because we are having square anyway, it will become positive. Are you getting? But anyway, always we cannot say that the y bar is big, y1 is big. Similarly here also x bar is big, x1 is big. We should not say. So only we are using a term differentiation. Yeah.
Okay.
Sir, for one doubt, sir.
Yeah, tell me.
Without a calculus, sir.
Yeah, tell me.
In the section 2, for base, should I take it as 12 or 60, sir?
Which one? The base.
Yes, sir. Base.
Base is only 40 only, right?
Sir, that is for section 1, sir. I mean, for the x-axis, sir. I'm asking for y-axis.
Y-axis, yeah, you have to take 48 by 12. That is the section we have divided. But you can take 60 by 12 and down you can take 28 by 12.
Okay, sir.
You can divide like that also, but the answer will be same only. It won't differ. Are you getting?
Yes, sir.
Okay, fine then. So now again I repeat, IXS is moment of inertia about XX axis. ICG is moment of inertia of the section with respect to centroidal axis. A is nothing but area of that particular section. Here it is 48 by 12 for the first section. For the second section it is 40 by 12. So H is nothing but y bar minus y1 square. Most of you will make a mistake. IXX means you will substitute x bar minus x1. Please make a note here. It should be y bar minus or y bar differentiate y1.
Me, sir.
Okay, fine. Second section, listen here. Second one, you have to help me now. Okay, whether this is the distance, am I right? What is this distance? Can you tell me now?
6, sir.
Yeah, no, for example, this is nothing but what? Can you tell me y2, am I right?
Yes, sir.
Okay, this distance is y2, am I right?
Yes, sir.
Okay, so when I am calculating, okay, with respect to this axis from here, so I know very well that this one will be, can you tell me? Y bar differentiate.
Minus y2.
Got it now? Did you get now? For the second section.
Yes, sir.
Okay. Any doubt in this? Second section means I am talking about this one. That is 40 by 12. Any doubt in this? H value? Okay, with respect to this. Similarly, we can say that the thing is like this. This is your, listen carefully, this is your x2. Am I right? So this distance I want with respect to axis, centroidal axis. This one will be, H will be x bar differentiate. Tell me how much it will be. X bar differentiate.
X1.
No.
Sorry, X2. Sorry.
Okay. Are you getting? Okay. Some of our friends asked out. Is it clear now?
Yes, sir.
Yeah, okay. So can we solve now? Or you need some time? Can we solve this problem?
Yes, sir.
Yeah, okay.
Yes, sir.
So what is the answer, sir?
Hey, we will solve the boy. Our friends also will solve. Okay. Then we can get it. Okay, now I am writing first one. If I want the total moment of inertia about this entire thing, so I have to calculate I1 plus I2. Okay. I1 is related to the first rectangle. I2 is related to the second rectangle. Okay. So when I am going with I1, this is nothing but ICG of 1 plus A1 H square. Am I right? Yes or no? Is it correct?
Yes, sir.
Okay, but this I1 will have, what are the parameters it will have? Tell me. What is the value of CG1? Can you tell me?
BH cube by 12.
Yeah, BH cube by 12 plus, here you can put B1 H1. You can take this one as H1, this one as B1, okay? And A, you know that B1 and H1, H square is nothing but, can you tell me what is this, H square? Whether it is Y minus Y bar or X minus X bar. I am
Y
taking
bar.
XX.
Y
Y
minus
minus
Y bar
Y
minus Y
minus
bar.
Y
Y
bar.
bar minus
minus Y.
Y bar minus Y.
Okay, so now listen carefully. B is, I knew that 12. H, I knew that 48 divided by 12. Please listen carefully. 12 into 48. And then you know very well that this is multiplied with, what is Y bar value? You have to say now.
22.63.
22.36
36.
minus 36.
Minus
36.
36.
36. Okay, it is differentiate. See here what mistake I am doing. Square I have to put. Okay. So please calculate the I1 value with respect to XX. Okay. That is 12 into 48 give. Any doubt? If you're having any doubt, you can ask me, please. 12 into 48.
576.
Okay. Yeah, very good. 22.36 differentiate 36 square. How much total value by I1 you are getting?
I1. 217756.56.
21756.57.
2.17 into, tell me.
10 raised to the power 5.
What is the unit?
mm raised to the power 4.
Please take down, guys. Okay, so now listen here. Move to the next session. Okay, listen. I'm taking the second one. Okay, this is the thing. You to calculate I2. So I2 when you are calculating ICG2 plus A2.
Students in
Here,
disturbance, can you mute everyone?
Sir, mute everyone, sir.
1 minute. Okay, listen here. So now we move to the second one. So when you are taking the second one, so please immediately you write B and H, then it will be easy. So 40 will be your B and 12 will be your H. Okay, now when you are coming here, so for better understanding I am writing BH cube divided by 12 plus B2 into H2. You can understand that how I am writing, and then Y bar minus Y2 whole square. You will understand now. So now B2 is 40 multiplied with 12 cube divided by 12 plus whole bracket you put, and B2 you know that 40 into, okay, you can write it down, 40 multiplied into 12, okay, and then you know that Y bar how much, 22.36, am I right? Differentiate, what is the value of Y2? 6.
6.
Okay, so tell me the value of I2.
So 13.42 into 10 to the power 4 millimeter.
42 into 10 power 4. When you are adding, please be careful. One it is in 10 power 4, another one is in 10 power 5. So now when I am calculating okay, 1 minute. AXX total, I know that I1 plus I2. So one is in 2.17 into 10 power 5. Please make a note clearly. Another one is 13.42 into 10 power 4. Please be careful with 5 and 4. Okay. Okay, now you tell me how much you got. Maybe 15 point something or 1.5.
Sir, that
Sir,
13.42 we can write 1.34.
3.51, sir.
Yes,
Into
sir.
10 power 5.
13.42 we can write as
We can write 1.34, no?
to 10 power
Yeah, very
Yes,
good.
sir.
How much you got totally? 3 point?
3.5 into 10.
3.519.
10 to the power 5 mm power
4.
4.
Please copy down now. No.
Yes, sir. Yes, sir.
Yes, sir.
Can anyone
Yes, sir.
help me how to calculate IYY?
Yes, sir.
What I have to put here?
Sir, ICG, sir.
No,
About
no,
Y.
IYY how to calculate? Again, I am having two sections.
IYY1 plus
Sir.
IYY.
Again, I am
So
taking
I2 plus
I3. No, no, no. I4 I am going instead of getting confused.
Okay.
Are you getting?
So what is I3, sir?
Now I am going to take moment of inertia with respect to YY axis of the first section. Okay.
Okay,
That is
sir.
I3. I4 is I am going to take the moment of inertia of the section 2 with respect to IYY. Is it okay? Or you want to keep it I1 and I2? Tell
It is
me.
okay. It
No,
is
no.
okay,
Which
sir.
one is
3
easy?
and
It's okay,
4
sir.
only, sir.
Oh, 3 and 4 will be better because you won't get confused. Okay. Now we are moving to the next one. IYY axis. Hope you are getting the screen clearly. I think so. Or whether I can increase a little bit more.
Yes, sir.
Yeah, you are getting. I think so. Now I3. See how I am writing. Again ICG 1 plus A1. Okay. Now listen here what I am writing. Got it now? Okay. Again I am writing. Again I am drawing the rectangle. See here. This is 12. This is 48. This is H. This is B. This is B. How I am writing? You see here. Please don't make any mistake here. X bar is how much we got? 12 point? Tell me.
12.3.
12.36.
12.3.
Okay. X1 how much we got? 6. Am I right?
Yes, sir.
Yeah. Now you see here clearly how I am substituting 48 into 12 cube divided by 12 plus 48 into 12, sorry, 12 into 48, but anyway, it's okay. Both are same only. And then here you will get 6.36 square. Tell me the value of I3.
Sir, 30,210.9696, sir.
No, no, it is better you tell me in terms of 10 power 4, the 10 power 4 or 10 power 3 or 10 power 5.
3.02 into 10 to the power 3.02 into 10 to the power 4.
Unit.
M
Okay.
power 4.
Yeah, this is the value
mm
of,
to the power 4.
yeah, very good. This is the value of I3. Please others calculate. I4 will be ICG2 plus A2 X bar differentiate X2 square. So now the rectangle of the I4 is, you know that up to here, that is 40 by 12. Okay, this is your B2, this is your H2. So the formula will be, I can write H2 B2 cube divided by 12 plus B2 into H2 in bracket. I think X bar you know the value 12.36. Differentiate, I think you know the value 20 whole square. Okay, am I right? So 20 square this one. Okay, otherwise I can write it separately if you are getting confused. 1 minute, I will write again so that you will understand much better. So B2H2 you know that. Okay, I think I can write it in the next slide so that you will understand much better. So this one will be x bar differentiate x2 square. Okay, whole. So when I'm writing this, I know that h2 is 12 and b2 is 40 cube divided by 12 plus, so I know that b2 is 40 into 12, and then I knew that another one x bar is 12.36, differentiate 20 whole square, this one. Okay, so tell me the value of I4.
9.2
9.01.
4 mm to the power 4.
9.2 into 10 power
4
10 to the power 4.
millimeter per
Okay.
4.
Okay, now can you tell me the IYY total? So what is that? I3 plus
1.222 into 10 power.
1.22 into 10 to the power 5.
Very good, very good. Into 10 power 4. Okay, for others, let them copy. Okay. 9.2. Please go through again, and then if you have any doubts, you can ask me now also. So can you tell me the total value? 12, 12 point?
12.22 into 10 to the power 4.
Into 10 power
Into
4
10 power 4.
Mm power
4.
4. Okay, this is IYY. Okay, now you got moment of inertia about XX, moment of inertia about YY. What are the other things we can calculate? Can you tell me?
Total I, sir.
Yeah, total I we calculated, right?
We can use that perpendicular axis theorem.
Yeah, what is the
Sir.
perpendicular axis theorem? Can you tell me?
Can it go back a minute,
equal
sir?
to IOX plus IOY.
Yeah, what is that? What is the value? What we will call that thing as? I total, please take down. I total is equal to, tell me, IXX plus IYY. Am I right? So what is the value now? Now you have to say, what is the value we got? 2.17, am I right? No. How much totally we got? IXX?
3.52. 3.3.
So 3.51.
3.5.
51 into 10 power 4 we got. IYY?
So into 10 power 5 it was.
Oh, sorry.
5, sir.
Okay. What about IYY?
1.2 into 10 to the power 5.
1.22 into 12.
0.22 into 10 power 5. Are you getting? So you can get I total
4.7,
4.7.
73.
Okay. Now you can calculate other things also. Can you calculate RXS and RYY?
Yes, sir.
How to calculate RXS? Root of? Am I right?
Yes.
Please calculate and
Sir,
tell me the
IX.
radius of gyration. Is it correct or I made a mistake? Do you remember all these terms? Radius of gyration, perpendicular axis theorem. Yeah. So that's only I said that once you understood the concept of moment of inertia, calculation is dead easy.
So one doubt.
Yeah, tell
What
me.
about area, sir? Which area we have to put? We have
Total
to
area. Total area. Oh, very good question. Okay, total area. So please take down here IXX total divided by the summation of all the areas. Got it? Okay.
Yes, sir.
Then you will understand much better. Here also same thing. IYY divided by. Whether this formula is correct, again I am asking, so you have to check and tell me whether RXS is equal to IXX by A or IYY by A.
IXX by
Correct, sir.
Correct? Okay, good. Okay. So when you are calculating IXX, whether you substitute Y bar differentiate Y or X bar differentiate X.
The Y bar
Very good.
differentiate Y.
Very good, very good.
Sir, I got RXS as 18.23 millimeter.
Very good, Ra. The unit you said, I'm happy about that. 18.23,
23, sir.
very good. 18.23 mm. Can you tell me RYY?
Yes, sir. 1 second, sir. Calculating.
Yeah, no problem. Sorry. I thought you have calculated. Is it interesting the way? Yeah, tell me.
10.75 mm.
Okay, very good boy. Okay.
So 10.76.
So why we are calculating this, I told you. What is the reason? RXS and ROY? Yeah, tell me, please.
So it's defined as the distance from that axis at which all the elemental parts of the lamina would have to be placed. That is, the entire area of the figure is assumed to be concentrated such that the moment of inertia about the axis is same.
Very good, very good. Okay. That is the reason of that. Okay. So once you have done, please tell me. I will teach you what is product of inertia. That's all. We are winding up the session. Okay.